Okay, hello, good day. Again, I'm Engineer Ernesto C. Prudenciade Jr. and welcome to my channel. So, we will discuss today free fall under constant acceleration. So, why is free fall under constant acceleration? Because it involves with gravity, no? G. G, no, is a constant function. So, in SI, that is 9.81 meter per second. Okay? So, let's start with this problem. Example problem number 20. A mango falls from a branch 5 meters above the ground. With what speed in meters per second will it strike the ground? Okay, so sige, let's draw first the mango. Let's say this is a mango, and there is a mango fruit, and it strikes the ground, no, here. So this is 5 meters. 5 meters. Okay, so given here is distance s equals 5 meters. So let's write first our formula, the three formulas, no, from the previous video. So if you still didn't see that, you can still review the video, no. So the first formula is Bf is equals to velocity initial, no, plus or minus acceleration times time. The second formula is S, velocity initial plus or minus 1/2 AT squared. Okay? So the third formula is Bf squared equals velocity initial squared plus or minus 2AS. Okay? So we will examine which formula to use. Okay? We have here two formulas that involve distance, S, and formula number 3, we have S here. Okay? So, by inspection, I think we can use the formula number 3 for this, because in formula number 2, it involves time, no? So, time is not given in our problem, so we will use formula number 3. Okay? So, solution, this is the formula to use, 2AS. Okay? So, BF, this is the question. Okay? So, BF squared, we have velocity initial, no? Because this is free fall, therefore, this is 0. So, we have to use plus because the gravity is constantly increasing. The mango falls from the tree. Okay? So, 2, what is A? That is our gravitational acceleration, 9.81 meter per second squared, times the distance, which is given 5. Okay? So, therefore, we can solve Vf, or the velocity final, equals to 2 times 9.81 times 5 square root answer. So, that is 9.990 meter per second. So, this is the final answer. Okay? Okay, so let's go to problem number 2. So, I already draw here the figure so that it will not take time. So, a man standing at a window, 5 meters tall, watches a falling stone pass by the window in 0.3 seconds, no? From what high above the top of the window was the stone released? Okay, so this is free fall, no? So from the word the stone was released. Okay, so this is free fall. Okay, so first given here is time, which is equals to what? Time is given, no, equals to 0.3 seconds. Okay, so again, we will write first our three formulas involved. So Bf equals velocity initial plus or minus acceleration times time. So the second one is VIT 1/2 A T squared. The third formula is Bf squared Vi squared plus or minus 2AS. Okay? So let's examine given T and given distance. Okay, from the formula given, we have distance and we have time. So most probably this formula will be used. Okay, so let's see. So S equals VIT plus minus 1 half G. I will replace A into G because our acceleration is 9.81 meter per second, or the gravitational pull. Given 5, no, we don't have the initial velocity, so BI. So time is 0.3. Let's use positive because gravity will increase as the stone go down. So 1 half 9.81 times the time is 0.3 squared. So we can solve for the velocity initial. Okay, velocity initial here from the start. Okay, this is velocity initial, no? And we can also denote this as velocity final, no? In the window. Okay, so velocity initial, no? We will use our calculator. So 5 minus 0.5 times 9.81 times 0.3 squared divided by 0.3. Okay, so we have here velocity initial 15.20 meter per second. Okay, so pasensya sa aso. So we have here velocity initial. Okay, so the question wants us to solve the distance, no, here from here y, which is the distance from the top of the window to the point of release. Okay, so that is y. Okay, so since we already know the velocity initial, that is also the velocity final at this point, no? The velocity initial here, because the stone was just released, so that is 0. Okay, we can now use this formula, the third one, because we have distance, we have this, so we have velocity final, we have velocity initial, we have acceleration, and this S is the unknown. Okay, using formula number 3, which is what? BF squared equals VI squared plus or minus 2AS. Okay, so we can substitute 15.2 squared equals velocity initial squared, this is 0, plus 9.81 times S, which is Y. Okay, so we can solve Y, which is equals to 15.2 squared, okay, divided by 2 divided by 9.81. Okay, so the answer is 11.76 meters. Okay, so this is your answer. Okay, so thank you for listening and hope you learned something from me. Bye.